Bem-vindos à segunda sessão do Android Sessions. Desta vez a Blip a fazer hosting do evento. Queremos agradecer à Blip por isso e por nos dar lanchar também, nas cervejas também é sempre bom. Queria primeiro, a Liliana vai apresentar a Blip, suponho que já devem ter ouvido falar, mas ela vai apresentar um pouco a Blip e depois então vamos começar com o speaker que tem o nome mais sonante que nós já tivemos no speaker do GDGPorto, o Joãozão, e a seguir com o Rui Mendes, não tão sonante, mas vamos então começar e obrigado por terem vindo.
Bem-vindos, obrigado. Acho que todos conhecem a Blip, nós estamos aqui neste edifício há cerca de 1 ano e meio. Pronto, eu não vou falar muito da Blip, se calhar no fim, quem quiser pode ficar, eu faço uma tour e explico quem está sentado onde, que projetos é que nós temos, acho que é a maneira mais fácil de vos mostrar. Pronto, espero que gostem e vamos começar com o João, que vai falar um bocadinho do que nós fazemos aqui e a difamada WebView. Espero que gostem.
Does anyone want to talk Portuguese? Okay. So, English it is. Who am I? I don't need to say my name again, because and I'm an Android developer here at Blip. And, well, who knows me knows that in the end what counts is a really good cooked meal, well-cooked meal. So, before I start talking, I want to do a disclaimer, because the moment you start talking about bringing web technologies into the Android stack, there's a flaming war out there, and I don't want to bring that into here, because I'm ultimately an Android developer, and that's what I like to do and what I enjoy the most. The agenda for this talk will be obviously talk about the WebView, and we'll give some insight on its origins and the iterations that happened over time, because it's good to know when you are doing or when you are using something, it's good to know the history and what the component has been doing. The most common use and, of course, abuse of the WebView. A basic WebView implementation, just a simple setup and some configurations. And this is the most interesting, which is the problems and challenges. It can be really tricky. So let's start to history and its effects from the past to the present. So what we will say about the WebView? What is the WebView? It's an extension of Android's view class, so it's like any other view. And it's a view that displays web pages, which means that just renders HTML formatted code, and you can show it easily for your users. So the WebView started to be, mainly it's a component from the SDK, and it's there since the beginning. And until KitKat, it was based on WebKit, which is an Apple thing, more or less. And then Google decided to move forward and use the Chromium. So they changed from WebKit to Chromium. And actually Chromium is an open source project behind the Chrome. So if you say Chromium or Chrome, you are talking about the same, basically. They released the KitKat with the Chrome 30, and then in another Android version, when the user updates their phone, they will get the 33 version on their web. So the web is tied to the OS, and the users actually need to update their phones to get the new versions of the web, which is not that good. But Google solved it, and since Lollipop, the WebView got unchained, which means that it becomes a bundle, or it is updated by the Google Play Store. The WebKit begins in the 90s from the KDE guys, from the Linux ecosystem, and well, basically they have two main components: the KHTML, which renders the HTML, and the KJS, which is the engine for JavaScript. Apple forked it and created the web core and JavaScript core. Then they launched Safari, and WebKit was. It's now they have a patent over the WebKit, but the web core and JavaScript core are still under a public license, so everyone can fork it or whatever. And then in 2010, they decided to redesign the WebKit and launch the WebKit 2. And Google did the same. If Google forked and the JavaScript core basically, and they created V8, which is their engine for JavaScript. And later on, they decided to announce the Google Link, which is the HTML brand. And WebView now. WebView now is a lot better than before. And they basically, when you are using the WebKit version, you get an HTML score of about around 2,200 and something. But when you are dealing with a new WebView, you get something like 500. So it's much better. But there's a slight, even though the WebView is bundled in the Chrome APK, so if you have to add the Chrome APK installed on your phone in order to use the WebView now, but they are not the same, exactly the same. It's still a separate component. Another cool thing you can do is you can debug your application in future versions of the Chrome. In order to do that, you need to have the Chrome you want to debug, or the Chrome Canary, for example, in your phone, and then you can enable it in the developer options and change the web implementation you will use. The Chrome dev tools that became available since the KitKat are, for me, the best thing you got from the change Google made. And this means that you can debug and inspect your web view like you do in web applications with Chrome. So you have the exact same features. Multi-process web view. This was added in Android 7, and this means that the web view now runs in a separate process. So if an hacker attacks your application, your web view-based application, you'll have limited access to resource because the web view is running in another process. In Android, even talking about the multi-process web view, this was added in Android 7, but you need to enable it manually through the developer options, and by default it comes disabled because at the time it was adding an increased time in the startup of the web view, but in Android 8 Google fixed it, and now it's enabled by default. Safe browsing in WebView is something that they added to. Safe browsing is really good in terms of security, because Google is looking for billions of URLs every day, and they find malicious URLs, thousands of malicious URLs every day. So if you want to add this to your WebView, you just have to do this, and if you want to test, this is useful. You just have to load this, and you'll see that your implementation is fine or not. So typical WebView use case. This is, for me, the intended use of the WebView, which is you have a full native application, but you need to show to the user some pre-formatted HTML content, like an end user agreement or an help page or something. And well, the web view suits that pretty well. It's really easy to do that. And this is for me the best use case scenario. Then you have web view in charge, which has two possible scenarios. Which has the first one says that the web view just renders the UI, and the business and data logic are still done in the native code. In this use case, you have a huge or a big JavaScript interface layer from the communication between the web view and the native side. Because imagine you have an application with a login form, and then the user clicks on the login, and that's all web. The web needs to communicate with the native side, so the native side will request some call to the network, and when they get back the result, they need to send it to the web view so you can render the page they want. The other scenario is when you have everything in the web view, so your application is like a box, but you still have some native features, so you still need to add some JavaScript interface and to communicate between the web and the native. Then you have web view as a wrapper, which is where you use something like PhoneGap or Cordova, and you pick up your website and you put in this framework, and you just run it on Android. This is similar to the scenario 2 I just talked, but in here you are tied to the framework. So if Google adds a new feature and you want to use that in your application, if PhoneGap or Cordova didn't have they have a thing called plugins, and if they don't have that, you can't have that feature on your application, which is bad. And well, it's another layer of possible bugs. You might end up having a bug and you don't know if it's the platform if framework you are using or if it's your code or wherever. It's preferable to use always native code to implement these things. Non-web view based alternatives like React Native, Xamarin, Flutter. Well, they all work pretty much the same. Most probably, the problems with this is that you most probably end up writing specific code for a specific platform. So they claim that you just need to code once and run everywhere, and that's not true. I have experience with Xamarin, not that experience with React Native, and didn't have to try Flutter. But in Xamarin, basically they have 100% mapping between Java and Java APIs and C#. So everything you need or you want to use you can use in Java, you can also use in C# with Xamarin. And as in the native approach, you can't have parity between your web and your native application, which is one of the greatest, the biggest advantage of having a web-based application, is that when you develop to the web, you also have that feature in the native right away. The web view setup. Okay, so the web, this is really, it's a really easy thing to do when you just want to load an URL, and that's it. Okay, so it can be treated like any other view. So you can instantiate or initialize your web view as any other view, and you just need to to load the URL you want to do. And if you don't need any other feature, you are good to go, and the URL will be there for you. You can also run some local assets if you want to bundle the assets in the APK. Okay, the web view itself is not enough when you are building the basic web application. So you need something like web settings, which enables you to use web features like local storage. It's really handy. And web settings, in web settings you have like more than 20 settings, 20 configurations. They come by default disabled, or almost of them, and you have to enable them manually. The most used are the local storage and enable JavaScript Interface, which is used to the communication between the web and the native side. So, if you are building a web-based application, you want to know what's happening in the web view. And this is where you'll need the web view client, which allows you to know the page cycles, like when the pages start loading, finish loading. And I added this one on commit and page commit visible, because on page finish just says to you that the application, the web view finished the loading, but it doesn't mean that you don't have obsolete resource, because it can be happening that, okay, the web view finished the loading, but there's still some rendering happening, and this last method is really useful for that, because after this one there is nothing rendering anymore in the web. This was only on Android Marshmallow, and well, it's really handy for error handling or receive error. This one, if this one's happened, it's because your web view couldn't reach the server you are trying to load. And with SSL error, when the SSL handshake is not successful, you have that error too. And this is where you will spend the most of your time if you are doing a web-based application, because when you have if you just load the load on URL in the web view and you didn't set the web view client, when the user clicks on an URL, a new link, the activity manager will pop up to the user, so you will need to choose the browser or whatever to open that, and you want the user to stay inside your application. So should override URL is exactly that. So by default, it returns false, which means your web view will deal with the loading URL. And if you need to perform some action on URL changing, you need to return true and perform that action yourself. Like if you catch a scheme like tel, you can open the telephone application and the user can perform a call for that number. Or if you receive a mail to scheme, you can start the Gmail or something with the message. Okay, let's see how we communicate between the Android web view and the native side. So for that, you just need to add a JavaScript interface. And you need to pass the class where you have the methods you want to expose to the web, and the name from where the web will call your methods. I'll show you two examples when you can expose, for example, a method to show a native notification. The method needs to be annotated with JavaScript interface. And well, if the web just wants to show a notification, they just have to to call something like Android dot show notification with a message, and a notification will pop up if you implement that on your site. And the next JavaScript interface I added here to tell you something, because the JavaScript interface is async, it's not running on the main thread, and if you want to perform some actions or operations on the web view, you need to take care and perform that on the web thread. Main thread. This is how your other web can speak with the native side. This is not important for us. But if you want to see. Okay, so how does Android talk with the web? So the opposite side of things. If you are targeting, or your main version is the KitKat, you need to use load URL and specifically say that you want to run JavaScript on the web. But if your main version is KitKat and above, you just should use the evaluate JavaScript. It's faster because it knows right away that it wants to run JavaScript. Okay, so we have the web view client, and now we have the web Chrome client. This is to perform actions on the web UI. You need to have a class with, or you need to for setup the web Chrome client. You just have to pass the class extending the web Chrome client, and then you can do things like writing permissions for the camera, so the web can use the camera of the device, or for a fast user to upload some photos. And in the end, I have a create new window. This one is really handy if you want to know if a target plan was triggered on the web view. So imagine you have an agreement with your web that everything that is target blank you will open outside of your app. The on-create new window is where you can see that and perform the operation. Chrome custom tabs are another technology that Google introduces that you can seamlessly show or load an URL on your application. This is used by a lot of applications. Imagine you have a native application and you want to load an URL, but you don't want the user to leave the application. You just call Chrome custom tabs and you show that URL without being so abrupt to the user. This has it's really, I don't know if anyone here just saw this if I was shown, but the performance they claim to have is really huge. So Chrome custom tabs opens the same URL in 2 seconds, and comparing to the others, okay, web view challenge. This can be interesting when you are building a web view-based application. So Android lifecycle can be tricky, right? So try to put another runtime on top of that. You have like 2 lifecycles running in a job. You might end up debugging invisible bugs. You don't know you have and logs that don't reach you. Web view bugs not being fixed for all specific Android versions. Simply there are web view versions that are simply broken, and Google won't update it or patch it with a fix. Users not updating their web view because they don't have the Play Store. That happens too. And the web view, it's hard to know. Imagine you have a user complaining, and you know the version is running on, but the version of the device. But the version of the device doesn't mean you know the version of the web is using, because you can have an HTC with Android 6 and a Nexus with Android 6, and the WebView version are different. And of course, performance, you'll never have the performance you can have with a native application, full native application. So my app is crashing, and I don't know why. Well, it might be a lot of things, some unlimited amount of things actually. I was just giving you some examples of what happened to me, and well, it can be an SVG in some Android version. Now imagine that SVG is just shown to the user, or it's not there all the time, and you can't even reproduce it on your site, or it's just shown in a location outside your country, or you even have a VPN to simulate that. Well, and it can break it, and your app will crash if the WebView you are using doesn't support that kind of SVG. Unsupported feature app. Okay, no. We can easily track when a lib you are using in Android crash or as a bug or something, but when it's a lib from the web, the things got ugly and you don't know, and you end up checking the package JSON for content, and you have to dig and dig, and it's not easy, just not easy to find those bugs, because a lib can, an updated version of a lib in a web, they might have added some method or some feature that the WebView in some version doesn't support, and it will break your app completely. So this is one of the latest known issues from Android 8 regarding the WebView, and these are the steps to reproduce it. Well, if you have multiple users on the device, so more than one user, and one of the users has a set work profile, which by default comes with the Chrome disable. Chrome has been updated with the Android WebView, which is the fallback when you don't have the Chrome APK installed for the WebView, and that Android system WebView hasn't updated, and the app will crash every time you go to the web. So great. This is in Android 8, and this is the link for the issue. There are some critical flaws in the WebView, but in terms of security. But the most well-known happens in the Jelly Bean and above and below. So it's 2018, maybe no one cares. But okay, the vulnerability happens when you have JavaScript Interface enabled, and that allows an hacker with a man-in-the-middle attack or something to install a remote shell in your device. So from there, he can access your shared preference, or he can send unwanted SMS on your phone, or provide a false front end to your phone. That's really good for phishing. Well, Google didn't and will not patch a fix for that versions. So if your users are running on 4.3, they still have this critical security flaw. And how to deal with it? Well, if the WebView you are running on the web page you are running on your WebView, if you want the servers there, it's hosted. If that's okay, you are fine. You do not redirect to external websites inside your WebView. And no one hacked at your servers. Well, it should be good. And okay, it's 2019. No one cares about everything. Network concerns. This is the last one, I think. So mobile mobile phones are not desktops. In the desktop environment, it's like a junkie. You can perform unlimited calls with no crash. But on WebView, you need to ensure that the web application you are running on your WebView is designed for mobile. It's really important. And you and web developers that are designing the web app, so it needs to care about the background state when you send the application to the background, because it's a typical use case. When the web app uses the polling technique, which is performing network requests from time to time, and the server, when you perform a request, the server is waiting for having the things to get back to you with the response. The native applications goes to background, and you are still performing network requests. Even if you pause your webview, JavaScript won't pause. To pause the JavaScript, you need actually to call something like pause timers, which will stop all the JavaScript. But that is a global configuration, so every webview that is running will be stopped. So that's not really good. So, and find a solution. This can happen without you being noticed. Okay, this was just it. No, I don't know. Maybe okay. I don't know if anyone has some questions, or if I just pass to my colleague.
Okay for me to start? Okay. So, good afternoon, everyone. My name is Mendes, and I'm here to to talk a little bit about Room database. Just a first question here: does anyone here work with Room database right now, for example? Okay, so you can go now because this is just an overview on the platform, so you will not learn anything here. So. Just first to introduce myself, I'm an Android developer at WeTech. Currently, I'm working on a solution to integrate the Google Assistant and Amazon Alexa with the set-top box WeTech produces. And I've been working on Android for about 5 years or so, and I'm a beer enthusiast. Okay? This is important for this talk because I was under the influence of beer when I accepted to do this talk, so I think it deserves a slide here. So, before talking about Room itself, let me talk a little bit about my background on databases. I started with probably where most of you have started also, which is the base SQLite implementation. So when we do this, we have tons of code that it is needed for basically just one table and one query. So we have to have all the fields declared. We have to basically extend SQLite open helper. We have to use content values. We have to basically do a lot of code for this. So it was not a great solution, but I used it for a long time, unfortunately. So the next step was moving to Realm. Okay, I was very excited with this. and because it was fast, easy to use, the tables basically were objects, so better for me, and I was using Java, and there was no boilerplate code, so it was better. But after basically adding complexity to my database, I started to get duplicate objects everywhere because the realm object, the realm tables basically need to extend the realm objects, and so we will need to map it to a different object. There was no easy way to inheritance, which was something that I was expecting from realm because it's object-based, okay? And the most boring of all is I would get random native crashes that I didn't know how to resolve, and I really didn't know. So that was a problem. So when I had the I moved to the room persistence library. It was announced like last year on Google.io, and I started working on it like 7 months ago. So, and basically, what is the room database? The room database, it's basically just an abstraction layer over the SQLite, and provides basically an API, so we can, that is annotation based like Dagger or Retrofit, and there are 3 main classes on the room. It's the room database, which is the main class for our database, that basically is where we fetch the data access objects. The data access objects are basically where we define the queries and how to insert, how to persist, and how to query the data from the database. And finally, we have the entities that are basically our tables on the database. So let's build a database with room. Not sure if you can see what is there, but basically, for the sake of this presentation, I created a small project so I can show you the steps needed for building a database. And what I propose we create is basically a table of players that are connected to some team. Okay, a team can have multiple players, but the player needs to have only one team. And then, just to complicate a bit, we will have a sponsors table that basically a sponsor can sponsor multiple teams, and the teams can have multiple sponsors. So it's a many-to-many relationship. So let's start from the basic. Let's build our players table. So for that, I'm not sure if everyone is familiar with Kotlin, so any questions, just let me know. But basically, what we do to create a table is we have the annotation entity that basically says this class is a table for room, and the fields that are described on our data class will be our fields on the table. So basically, this creates a table with ID, number, and name. We just need to have a primary key, so we know which of the fields will be the primary key. And in this case, I put there auto generate true. It's not needed; it's optional, so you can use it or not. So with that, we create the table players basically. Now we have to create the data access object, basically the class that will gives us access to that data. So for that, if you are familiar with Retrofit, it's similar to where when we describe our REST API or something. So basically, we add the annotation DAO, and we define an interface with our methods. So for the players, for example, let's start by a simple one, which is, okay, let me query all the data from the table players. So for that, we basically use the @query notation. We provide an SQLite, an SQL statement. So we have to know a little bit of SQL to use room. But the good thing is that Android Studio, and also when you are compiling, they will give you errors if you are failing on writing the SQLite. So it helps you a lot. So basically, on that, I create a get all players that returns a list of players, and this will return all the players on the database. You can see that I am returning a list of players, so room handles this for me, but I can return other things, like if I'm using the recent Android components, architecture components, I can return live data directly, or if I'm using RxJava, I can return a flowable instead. So there are a lot of things you can do with this. But for the sake of this presentation, let's stick to the simple list of players. So in order to insert a player to the database, okay, we have the tag insert. Okay, it's easy. Just once again, just add a function with it, pass a player as parameter. In this case, I'm passing a player. I could pass a list of players that room will handle that for me, and it will instead of introducing only one, it will insert the list of players. So, and also I can update. I have a tag update, or I can insert, for example, with an option which is the strategy for the case of conflict. So in that case, I simply put, in case of conflict, just update my data with the new data. So for now, this is really straightforward. Okay, I forgot that I also have this slide. So we also have the tag delete to delete a player. It can be, once again, it can be also a list of players. But if we want to delete all the database, we need to use the query statement and put the delete from in the table we want. So that's basically for now. We'll close our data access object, so we can basically insert, update, query our data and delete it. So we have a data access object complete. So the last part we need to do is create our database class. Our database class will be basically an abstract class that has inside it has an abstract functions that will provide us the players the players DAO, or all the DAOs, all the data access objects of our database. We don't need to implement it. Room will implement it for us. So we only need to put the annotation database, define which entities are available on our database. In this case, it's the players only, and also define a version for it. So, okay. Finally, we simply, to fetch the implementation after compiling, we simply call that database builder method from room with a context, our class that contains the database. We give a name to our database and we call it build. After that, we have access to our data access objects, and so we have also access to our data. So it's that easy. Just with that, we have all the players available for us. So that was easy, but okay, we want a little bit more complexity normally on our application. So let's start with putting some arguments to it. So imagine that we need to fetch a player by its ID. Okay, it is possible to use arguments on our queries because the queries will be compiled by room. They, once again, Android Studio gives us errors if we don't put a right field on that. So we basically can send an argument, in this case, the player ID argument to the room and use it as parameter on our query. This basically will return a player, a single player, with that ID. We also can pass an array of ints, and basically we can pass what we need for the queries if we use it the right way on the SQLite statement. So that's great, okay? But for now we are only using simple objects. We are basically using ints, strings, okay? That's easy, okay? But let's do a little bit more. Imagine that we have this data class which has the games played, the goals, and the number of assists of a certain player, okay? And we want to add it to our table players. The first thing that comes to mind for a programmer, at least for me, is okay, I will put here the stats object and it will work for me, but it doesn't, okay? It's not that straightforward. But it's easy to a easy way to make it work is use the tag embedded. This tag embedded, what it does is basically on the player class, it has the fields from stats. So, in fact, this is the only slide with generator code, don't worry. So, in fact, our table will not only have the ID number and name, but will also have the fields from the stats object. You can display the goals and assists. This is cool because Room handles this translation for us. So we will receive our object with the stats object in it, and it will be stored with the flattening of the object. So that is good, but that's not enough. Imagine you have you want to store a birth date, and this birth date is a date. Okay, it's a date object. The date object is not as straightforward as our data class. It's a more complex data. So we need to create a converter for it. We need to basically teach Room how to store a date object on the database. For that, we have this annotation, which is type converter. The type converter basically tells Room how to store. Right? The from time state basically creates a date from a long, and the date to timestamp creates a long from a date. So what Room will store in the database will be along with the timestamp and not the date object itself, but it handles this conversion by using our type converter. So in order to make the type converters work, we simply need to add that information on our app database class, and our app database class will basically has this annotation which is type converters, and we can put multiple converters on that if we want to separate them by type, for example. So we can store data objects now. Okay, but you now can say you are able to do a lot of things right now, but yeah, you only use that entities. We have to have all these entities. Basically, we can only have the tables and nothing more. That's not exactly right. We can manipulate the objects that Room returns to us. For example, on this query, this last one, we want to fetch all players' names. So we do a simple query to select name from the table players, and we can simply return, we don't need to return a list of players. Okay, we can simply return a list of string, and Room will handle this for me and return me the list of players. A more complex problem will be, let's say we have this class. We want to show the top scorers of whatever league we are playing. And we have this class, the top scorer class, which simply has the name of the player and the number of goals he has scored. Okay, so what comes to mind is basically, okay, let me just tell Room to return this as a top scorer object, but that doesn't work that directly. Because why? Because basically he can match the name. Okay, we are fetching name and goals from the database, and he can match the name to the top scorer, but he doesn't know where to put the goals variable, because the field that we have there is number of goals. It's a different name. So if we want this to work, we simply have to add on the data class. We have this annotation which is column info, and we say, okay, this variable simply has the reference which is goals, the goals column on the database. And with this, we can return a list of top scorers instead of the full player list. So that's something we can do. So now one thing that sometimes it's more difficult. It's okay. Now we want to have relationships between tables. So let's introduce the teams table on our database. So That is something that I already showed you. So we create the entity team, the data access object for the teams, and we add it to the entities of our database, and we provide the teams.all method so we can access the data access object of the team. So how can we link this to our players table? This is possible by, basically, we introduce a new field on our table players, which is the team ID that will represent the team the user is associated, and then we add a foreign key to this. Okay, it seems like a lot of things going on, but it's quite simple. We simply have a foreign key specified that says, okay, the entity that the foreign key belongs is the team, our team table. The parent column is the field from the team class that we want to match, and the child column is basically the field on the players table that we want to have this relationship. So basically, the team ID will match the player team ID field. So that makes the relationship. The on-delete part of it is basically I'm saying to Room that, okay, if a team is deleted, then delete all the players of this team. I don't care about them. We can do that, or we can set a different strategy, like set a default value or so on. Okay. Also, imagine that you want to add uniqueness on your database. For example, a team can only have a player with a certain number. Okay, we cannot have players with the same number on the same team. So we can add an index for it that will contain the number of the player and the team ID, and we say, oh, this needs to be unique. So Room will not let you introduce a new, will not introduce a similar object for it. So now, how can we query our data? Imagine that we want to query to a class which is team with players. Okay, we have like a variable team and a list of players. So this will return our team with all the players belong to that team. How can we query it? So on the data access object, one possible solution, which is not great, will be changing our data access object to be, instead of being an interface, being an abstract class, so we can provide methods that are already implemented. Okay, and for that we can use the transaction tag, and we basically do it manually. We fetch the teams, then for each team we will get all the players for that team, and then add it to a list of team with players and return it. So this is a possible solution, but it is possible to do better than this. So we can use the annotation relation. This annotation basically works similar to the foreign key notation, where basically the parent column would be the field on the team entity, and the entity column will be the child column that will belong to the player entity. So in here we are making this relation. We are telling Room, okay, this field is based on a relation between two tables. In fact, you don't have to have the foreign keys on the entities. You can only have this. What you will lose with that is the ability to do a cascade delete or so on, to have a strategy to the deletion process. The rest you can handle simple by doing this. So if we do this, we now can directly return a list of team with players directly without no effort, basically. Notice that I still maintain the at transaction, the annotation at transaction, because Room will generate multiple queries for this. We only say, okay, select everything from themes. But since we are sending the theme with players, which is an object that contains a relation, Room will build all the needed queries to return that information for us. So we need to maintain that transaction. So every single query is done on a single transaction on SQLite. So mind blowing, right? So to end this part, to end our database, we are simply it's only missing the sponsors part. Okay, the sponsors part is the most tricky one because we can have multiple sponsors sponsoring a team, and we can have and the team can have multiple sponsors. So it's many-to-many relationship. So for that we need to create a secondary table as usual. So let's start by creating the sponsors table, which is nothing more than we've done so far, and then introduce our join table. This join table will basically simply contains a reference to the team ID and a reference to the sponsor ID. Okay, this will every entry on this table will contain a relationship between a team and a sponsor. So it's once again it seems a lot, but it is not actually. The table name is just the name we give to our table. Then we say that our primary keys is basically team ID and sponsor ID combined. So both ones form one single primary key. And then we have, in this case, similar to what we have on the one-to-many relation. Since in here we have two foreign keys, we add two foreign keys here. Okay, but the logic is the same. We have the foreign key from the team class, where the ID, the parent column ID is from the team class, the child column is the field on the team sponsor join, and we also put cascade delete on it, so we don't have relations that don't care. We don't care anymore. So, and for the sponsor class is the same. So it's simply using foreign keys. Then we want to query it. First, okay, on our data access object, we simply put an insert, and to query it, you will need to learn a little bit of SQLite if you are not familiar with it. But we basically do an inner join with team sponsor join and the table we want to fetch from. So basically, in this case, we are fetching all the teams for a certain sponsor, using the sponsor ID as parameter for that. And it's also possible to get the sponsors for a team, which is basically inverting the SQLite statement. So for that will be it. So finally, to finalize our database, we simply need to add this new class on our entities for the database, then add it to our data access, the methods for our data access object. So you might say, okay, this was great, Bloom is great, everything is easy, so migrations are easy. No, they are not. Migrations, if you are familiar to migrations on basically every platform, are a pain in the ass, basically. So if you don't care about the data, they are easy. You just say, okay, let's destroy everything. We don't need our data for nothing. So fall back to destructive migration, and it will work. You lost the data, but it will work. But if you care about the data, the first thing you have to do basically is change the version of the data. Every time you do a change, you update the version of your database. Then you have to create a migration object, basically, that will provide will provide the change that we need on the schema. The problem here is everything needs to be done via SQLite statement. So In this case, it's a simple one. It's like creating a table with 3 elements. But when we have large tables, or when we have basically when we want to change just one field of or add one field to our table, it's a little bit more tricky. Okay, so after doing that migration, we need to edit when we are fetching our database. We need to we use the method add migrations, and we put all the migrations we want. You can do basically migration from 1 to 2. You can do migration from 2 to 1 if you want. You can do migrations for everyone. What tells Room that is basically we are extending their migration from 1 to 2. So that's it. So just to finalize this, many of you might be wondering about performance. Okay, this does everything for us, so we don't know what is happening there. So you probably won't see a thing, but Room is the second on the right, and it is based on this on a GitHub project, which is not mine. Okay, it's from some other guy who investigate this and has sometimes for a big project, plus a data, huge data, minimal. So, and in all of it, the performance was very good. It was sometimes better than GreenDAO, and some other times not exactly, but it was really good in performance. And if you heard some talks from Google I/O this week, they are still working on it, and they at least say they are improving the multi-threading querying, so it is still getting more performance. So just to finalize, for me the pros of using Room will be you write a lot less code. You have the compile time checks, which are great because we are using SQLite statements with arguments from Java or Kotlin, and Android Studio warns it and gives us error, and we also have compile time error if it passes Android Studio check. It has great performance, and one thing which is important is it has integration with the latest features from the architecture components, because Room is part of this architecture components from us. Basically for me the cons on Room is, okay, you have to effectively know SQLite, okay, because you will write SQL statements if you want complicated queries, and the migrations. But to be honest, I didn't found yet a good migration system. So that's it. So that's all for me. You have on my GitHub, I put some code with this database, so you can test it, and I have the link also for the developer Android architecture room. So that's it. Any questions? Okay, no. On migration? Exactly. That's another downside.